Hello everyone, welcome back. I am Chetan Rajoria from ABES Engineering College, Ghaziabad. I welcome you all to this video lecture series. I am taking up unit number 1 of the subject Fundamentals of Mechanical Engineering. The subject code is BME 101 or BME 201. So this is the sixth lecture of the series, and prior to that, covered up few numerical problems based on the concurrent force system, and one problem has been taken on the basis of on a free body diagram as well as conditions of equilibrium. So in this lecture, we will take one more problem based on FBD and the conditions of static equilibrium. So let's start. So students, this is the problem. Two smooth rollers P and Q having radius 25 centimeter each and weights 500 Newton each rest in a vertical channel having vertical walls. So this is a vertical channel, okay, having two vertical walls, and there is a horizontal ground over there, and two smooth rollers are placed between these two vertical walls. The size of these two rollers are exactly identical because the radius is same, 25 centimeter each, and the weight of these two rollers is also same. It is 500 Newton. The gap between the walls is 90 centimeters. So, okay, so this gap has been given 90 centimeters, the gap between these two walls. What we need to calculate? Calculate the value of reactions at point A, B, and C. So we need to find the reaction at point A, the reaction from the left wall, B, the reaction from the right wall, and C, the reaction from the ground. So these are the reactions which we need to calculate here. So this is the problem. How to solve this problem? We will start from this upper roller Q, because less number of unknown variables are there. Only two unknown variables are there. In case of roller P, we can clearly observe that there are three unknown variables, the reaction from point A and C, as well as the common reaction between these two rollers. So we will start from the free body diagram of this upper roller Q. But before moving ahead, we need to analyze the common reaction between P and Q, especially its inclination. What is the inclination of this common reaction, PQ, from the center of the first roller to the center of the second roller? We need to analyze this part first. After that, we will analyze the free body diagrams of these two rollers one by one. So how to find the inclination of this common reaction? If we carefully observe this diagram, we can clearly observe that we can create a right angled triangle between the centers of these two rollers. So let's draw a common line between these two centers of the roller. So this is the line joining the centers of these two rollers. Let's drop the perpendicular from the center of the upper roller. Because the radius of the upper roller is 25, therefore this gap will also be equal to 25, right? Similarly, if we drop a perpendicular from the center of the second roller P, so this distance will also be equal to 25 centimeter. Now the total gap, overall gap between these two vertical walls is 90, and these small distances are 25 and 25 each. So what will be the horizontal gap between these two centers? The horizontal gap between these two centers will be 90 minus 25 minus 25. That is 40. This horizontal gap will be equal to 40. And what is the value of this hypotenuse of this right angled triangle? This hypotenuse will be the summation of the radius of these two rollers. it will be equal to 25 plus 25, that is 50. Using these two dimensions, 40 and 50, we can calculate the angle of this common reaction. Suppose this angle is phi. So how can we calculate phi? We can use a trigonometrical ratio which consists of the base and the hypotenuse. So we can use cos phi. Cos phi is equal to base upon hypotenuse, that is 40 upon 50. So it provides us the value phi is equal to 36.87 degrees. So this is the inclination. Now let's consider the free body diagram of the upper roller. It is the weight. What is the magnitude of the weight? It is 500 Newton. Next, the reaction from this point B, it will be horizontal and towards left hand side. So somewhere here is point B. The reaction will be passing from the center of this roller. This is RB. And the reaction at the point of contact of these two rollers, somewhere here will be the point of contact of these two rollers. The reaction will be once again towards the center, and it will go like this. Suppose this point is D. So this is RD. Once again, this is a 3-4 system, coplanar 3-4 system under the conditions of equilibrium. So we can use Lami's theorem here. So either we can use Lami's theorem or we can use the conditions of equilibrium. In the previous lectures, we solved a similar kind of problem using Lami's theorem. So now, for learning point of view, we will use the conditions of equilibrium, means equilibrium equations. So this angle is 36.87. So let's resolve the forces in the horizontal and vertical direction to obtain those two equations. Summation of forces along x-axis is equal to 0. So RD cos 36.87 minus RB is equal to 0. So this is the first equation. And if we write the second equation, RD sine 36.87 degrees minus 500 vertical components is equal to 0. So this is the second equation. So this is the equation for the horizontal forces, and this one is the equation for the vertical forces, that is sigma Fy equals to 0. From the second equation, we can clearly observe that we can get the value of RD. So RD is equal to 500 upon sine 36.87 from equation number 2, second equation. So the value is 833.33 Newton. Using this value, we can calculate the value of RB. If we put the value of RD in the first equation, we will get the value of RB. So RB, how to calculate RB? From this, RD cos 36.87. Cos 36.87 is equal to RB from second equation. Sorry, from the first equation. So RB is equal to 666.66 newtons. This is our first answer. So we have found the reaction from the point B. Now we will consider the second roller, roller P, and its free body diagram. So let us draw the free body diagram of the second roller. The weight of this roller is 500 Newton once again. Similar weight is there. The reaction from point C will be vertically upwards from the center. So it will pass through the center like this. This is RC. The reaction from this common point, okay, this is the point D. The reaction at point D will be inclined downside. Previously, we considered this direction inclined upward on the roller Q, and now we will consider inclined downward according to action and reaction principle. So this is 36.87 degrees, but inclined downward direction, RD. Next force, the next force is the reaction from point A. It will be in the right-hand side direction, like this. This is RA. It is acting at point A, but we are showing this force at the center to show the concurrency at the center. So this is the complete free body diagram of the second roller, roller P. We will resolve these forces as usual. Summation of forces along x-axis is equal to 0. How to write the first equation? RA minus RD cos 36.87 is equal to 0. This is the third equation. And for the vertical forces, summation of forces along y-axis is equal to 0. We can write RC minus 500 minus RD sine 36.87 is equal to 0. Okay, so this is the first equation, third equation, and this one is the fourth equation. Using these two equations, we can directly get the value of RA and RC because only these are the two unknowns, RA and RC. From the equation number 4, we can directly get the value of RC. So RC is 1000 Newton by calculation. And if you put the value of RC, no, it's not desired, it's not necessary. This is only the answer. You can see that another answer which was desired in this question. We can get the value of RA from this equation directly, equation number 3. So RA is coming to be 666.66 Newton. So these are the other two answers. So what we did in this question, first of all, we found the inclination of the common reaction between these two rollers using the basic trigonometry. After that, we analyzed the free body diagram of the upper roller. We solved the conditions of equilibrium of the upper roller and found the reaction RB and RD. We used this RD reaction for the lower roller, and using this reaction, we found the remaining two reactions, RA and RC. So in this way, the question has been solved by repeated assumptions, or you can say repeated application of free body diagram as well as the conditions of static equilibrium. Okay, so thank you so much, students. Thank you.